Hello viewers, now let's solve this question. We have in the triangle ABC, angle CAB equals to alpha. D is a point on AB such that AD equals to 3DB, okay, and ACD equals to BCD equals to 15 degrees. We want to prove that cot alpha equals to 6 minus radical 3. Alright, so in this case, the first thing is to draw the triangle, to analyze the problem, and let's see how we can prove that cot alpha is equals to 6 minus root 3. Okay, so we are giving triangle ABC. Okay, we're giving triangle ABC. So let's say we have ABC. Okay, now angle CAB is alpha. Now D is a point on AB, that is D is a point on AB. D is a point on AB such that AD is equals to 3dB. That is AD equals to 3dB. That is AD equals to 3dB, which means AD, equals to 3dB. That's what we are giving. So, which means this implies that AD ratio DB, that will be equals to 3:1. That will be equals to 3:1. Yeah. Now, ACD equals to BCD equals to 15 degrees. So, which means, yes, so we are going to join C to point D. We have to join C to D. Okay, so when C is joined to point D, so we now have triangle ACD with the angle at C to be 15 degrees. Okay, we also have BCD, which is 15 degrees. Okay, yeah, okay. So which means AD will be 3, then DB will be what? Will be 1. That is because I said AD equals to 3dB. Okay, means AD ratio DB will be equals to 3:1. Okay, that's it. Alright, so the next thing to do from here is to use sine rule in the triangle ADC or ACD, and BCD. Okay, yes, we use sine rule in the what? In the triangle ACD and BCD. Okay, so now we have our step 1. Use the sine rule in the triangle ACD. So if you use sine rule in the triangle ACD, so we have this would be AC, this would be CD, then we have AD over, so it will be AD over sine 15 degrees, equals to AC, that is AC over what? That's AC over sine, then we have ADC, sine ADC. So let's call this equation 1. Yeah, equation 1. Now step 2. We again use the sine rule. Use the sine rule in the triangle BCD. In the triangle BCD, that's BCD, so that we can say that BD all over sine 15 degrees, will be equals to BC, BC all over sine BDC, sine BDC, yeah, sine BDC. So this becomes equation 2. This becomes equation 2. Now, so we know that now, because we consider triangle ACD and triangle ABCD, now there's a relationship between angle BDC and angle ADC. They are related because both angles are what? Supplementary angles. Okay. Now, let me write by using the relationship between angle ADC, that's angle ADC, and angle BDC. Okay, now ADC and BDC. Okay, ADC, this angle ADC and BDC. Okay, this angle and this angle. Okay, by using the relationship between angle ADC and BDC. Now we know that ADC and BDC are supplementary. They are what? They are supplementary angles. They are supplementary angles. They are supplementary angles. So we can conclude that now we know that the sum of these two angles will be what? Will be 180 degrees. Okay, so we can conclude that now by equating the two sine equation. Okay, by equating the two sine equation, or we can say equating the two sine equation, that is the two sine equation. Now we know that when we equate the two sine equation from here, we know that from AD over sine 15 degrees equals to AC over sine ADC. Okay, we can have AD over what? AC, okay, to be equals to sine 15 degrees over what? Sine ADC. Note that, okay, this is very important. Okay, then also from BD all over sine 15 degrees equals to BC over sine BDC. Okay, now we can also write this to be what? BD all over what? BC to be equals to sine 15 degrees all over what? Sine BDC. So now, so these two will now be equated. So we can now equate these two will be what? We are going to equate these two. So when we equate this, we can now have AD all over AC to be equals to BD all over what? BC. Okay, AD all over AC equals to what? BD over what? BC. And we have from here that AD equals to what? 3BD. DB rather. So we know that, we recall that AD equals to 3 multiplied by what? DB. Okay, so which means this will be 3 DB all over AC equals to BD all over what? BC. Okay, now DB will cancel out. Okay, then we'll be left with, from here we're going to have AC to be equals to 3 BC. Okay, we just have to what? We just have to establish this relationship between AC and what? And BC. Okay, now like I said, from my step 1, okay, use the sine rule in the what? In the triangle ACD, this triangle. Okay, so which means AD is opposite angle what? 15 degrees, and that will be AD over what? Sine 15 degrees. Okay, then AC, this side, okay, is opposite what? Opposite angle ADC. So that's why we have sine ADC, and that is equation 1. Then step 2, use the sine rule in the triangle BCD. Now we have BCD because in the question we have ACD equals to BCD equals to 15 degrees. So triangle BCD, in triangle BCD we have BD to be opposite angle 15 degrees. So that will be BD over what? Over BCD. Okay, then we also have this other side here, that's we have BD over what? Over sine BCD. Okay, then we also have BC all over what? All over sine BDC. Yeah, all over sine BDC. But BDC and ADC both are supplementary angles. So because they are supplementary angles, that's why I said by using the relationship between ADC, we can see from here. This is ADC and BDC. Okay, the relationship between them, that is angle ADC and BDC, are supplementary angles. So these two will now be what? We're now going to equate the two sine equation. That means they will be equal. They will be equal. Okay, so that's why from equation 1, from AD over sine 15 equals to AC over sine ADC. Okay, we can express the ratio of AD to what? Ratio of AD to what? AC. Okay, to be equals to sine 15, okay, degrees over sine ADC. Then from BD over sine 15 degrees equals to BC over sine BDC. Then we can write BD over BC to be equals to sine 15 degrees over what? Sine BDC. So which means these two, they are equal, because from here I said they are supplementary angles. So we can say angle ADC equals to what? Angle BDC. Okay, angle BDC. Now this is very important. Now, okay, so this is very important. Okay, so we have ADC to be equals to BDC. So we've been able to establish the relationship between AC and BDC. So which means the triangle we are going to use in order to prove that cot alpha equals to 6 minus radical 3 will be triangle ABC. Yes, let's use triangle ABC. So we have, so now step 3, use the sine rule. Use the sine rule in the what? Triangle ABC. Yeah, triangle ABC. Now let's analyze ABC. So we know that AB, okay, AB, we have AB over what? Sine what? ACB is equals to, again, we also have AC, we have AC, okay, AC over sine ABC over sine ABC. Okay, so we have AB over sine ACB equals to AC over what? Sine ABC. Now let's come back to what we have here. We have AC to be equals to, okay, we have AC to be equal, okay, it has to be in terms of BC. Okay, so we have AC and BC. So we know that AC, okay, AC over sine ABC. Yeah, AC over sine ABC. Yeah, AC over sine ABC. Then BC over sine BAC. Okay, then we also have BC over sine BAC. Yes, sine BAC. We have AC, this side, opposite angle what? ABC. And then also we have BC, opposite angle what? Angle BAC. That's BAC. Because remember, it is because we want to prove that cot alpha equals to 6 minus root 3. That's why it must be AC over sine ABC equals to BC over sine BAC. Okay, yes, I mistakenly used it the other way. Okay, so now, which means that now we know that AC equals to 3BC. So we know that, okay, let me use recall. Okay, we have AC equals to 3BC. So I'm going to write AC as what? 3BC. Okay, we have 3BC over sine ABC. Okay, that will be equals to BC over sine BAC. Okay, we have sine BAC. Now, this will cancel out. Now, this will reduce to sine 3 over sine ABC. equals to, now sine, now BAC is alpha. Angle BAC, okay? Angle BAC is alpha. Note, angle BAC equals to alpha. Angle BAC is alpha. So from here we have 3 over sine ABC to be equals to 1 over now sine BAC, and we know that BAC is what? Alpha. From here, BAC is alpha. So this is BAC. So that means we have sine alpha. We have sine alpha. Now we can cross multiply. So if we cross multiply from here, we're going to have 3 sine alpha equals to sine ABC. Okay, now to get ABC, we know that ABC will be angle ABC. We know that the sum of, if we use what we call angle sum property of triangle, it means we are going to add BAC, BCA, and what? And ABC. Okay, so using angle sum property of triangle, so we know that ABC plus B, we have BCA, okay, plus then we have BAC. So we have BAC, and that equals to 180 degrees. 180 degrees. Now we know that angle, now we have ABC. ABC is what we have here. Okay, we have sine ABC. This is equals to sine ABC. Okay, sine ABC. Okay, but we want to express ABC in terms of other angles, and we know that one of the properties of triangle, okay, apart from the identity property of triangle, where we have A plus B, you know, sum of A plus B greater than C, sum of A and C, okay, when A plus C will be greater than B, you know, that's identity property of triangle. But in this case, we're going to use what we call angle sum property of triangle, which states that the sum of interior angles in a triangle is equals to 180 degrees. So from here we have ABC plus, now what is BCA? BCA will be 30 degrees. Okay, now BAC will be what? Alpha. So this will be 30 degrees. It is 30 degrees because we have to consider everything here. That's 30 degrees. Then BAC is alpha, which is equals to 180 degrees. Okay, now so I'm going to make this guy go to the other side so that ABC can be equals to 180 minus 30. Okay, then minus alpha, so that ABC will be equals to 150 minus alpha. So which means we have sine ABC. So ABC is what? 150 minus alpha. So we have, so from here, okay, we have 3 sine alpha equals to sine 150 minus alpha. 150 minus alpha. Don't forget, we want to prove cot alpha equals to 6 minus radical 3. Okay, so what we're going to do next is to what? Is to use the compound angle formula for sine. That is the trig identity. Okay, so using trig identity, so we have 3 sine alpha. So if to expand this, we are going to have sine 150 cos alpha, then sine alpha, then cos 150 degrees. Okay, so what is sine 150? Second quadrant. That will be 0.5. That's 1/2. Okay, yeah. So this will be 3 sine alpha equals to 1/2. Yeah. Then cos alpha minus sine alpha, then cos 150. That's going to be that will be negative √3/2. okay, negative root 3 over 2. So in this case, we have sine 3 sine alpha equals to, this will be 1 over 2 brackets cos alpha, then root 3 sine alpha, root 3 sine alpha. Okay, so what is important now is, from here we got this to be 1 over 2 cos alpha, because sine 150 is 1/2. Then sine alpha, okay, we have sine alpha, then cos 150 degrees, that will be minus radical 3 over what? Over 2. Okay, so, and then we factor out 1/2, which is what we have here. So this will be plus, that will be plus radical 3, okay, plus 3. So let me multiply this side by, so multiplying this equation by 2. So 2 multiplied by 3 sine alpha, that will be 6 sine alpha. Now 2 multiplied by 1/2 of this, then the right hand side will reduce to cos alpha plus root 3, okay, sine alpha. Okay, we're almost there. So the next thing to do from here, okay, now let me bring this here. Okay, let me bring, so from there we have, from what we have there, from here, I'm going to move this down to this side. Okay, so let's continue from here. All right, so we have 6 sine alpha equals to cos alpha, then plus radical 3, okay, sine alpha. Because I want to obtain cot alpha, and I know cot alpha is what? Cos alpha over what? Sine alpha. Now remember, cot alpha is what? Cos alpha over what? Over sine alpha. So which means I'm going to divide this by what? By sine. Okay, so we have 6 sine alpha equals to, let me write it again, cos alpha plus radical 3 sine alpha. Okay, now divide, let me write it clearly. Okay, divide both sides by what? By sine alpha. So this will be 6 sine alpha over what? Sine alpha equals to cos alpha over what? Sine alpha, then plus radical 3 sine alpha over what? Sine alpha. This guy will cancel out. Okay, so we have here that we have cos alpha over what? Sine alpha, which is what? Which is what we have here as what? Cot alpha. Now this will reduce to what? 6, and this will be cot alpha plus radical 3. Remember, this is what we are looking for. We want to prove why cot alpha equals to 6 minus radical 3. So I'm going to move this to the left hand side. Okay, so when we move this to the left hand side, okay, let me just write rearrange the equation. Okay, so that cot alpha, okay, becomes the subject of the word, of the formula. So when to do that, so I'm going to move this down here. So I have 6 minus root 3 equals to cot alpha plus root 3 minus root 3. So what have I done in this case? That is, I subtract radical 3 from both sides, so that this will become cot alpha equals to, cot alpha plus radical 3 minus radical 3 equals to 6 minus radical 3. So this cot alpha, I'm going to bring it to the left hand side and move this to the what? To the right hand side, because we know that equation, in every equation, the equality sign will always link all parts, together. That's the left hand side will be equals to the what? The right hand side. So we have cot alpha equals to 6 minus radical 3. And we just proved that cot alpha is equals to 6 minus what? Radical 3. The noblest pleasure is the joy of understanding. Bye-bye.